effective annual rate, or EAR. The idea is the following. When interest payments are received more than once a year, interest rate effectively earned over 1 year will be higher than the stated interest rate. Why is that true? That's because of the interest on interest, the extra money that you would be able to earn over 1 year. And so what we need to do is, or what we are actually going to learn now is how we convert the interest rate per year, which is given to us, the so-called stated interest rate or the quoted rate, into the effective annual rate, EAR, that, that correctly reflects all the additional interest on interest that's going on. And then later, we will look at how the effective annual interest rate can be used as the correct interest rate in all the calculations which we have just done to find the present value or the future value of a single cash flow or of many cash flows or of annuities or perpetuities. Let's look at the following example. Let's see what the effective annual rate is all about, based on this very simple example. You deposit $100. The quoted annual rate is 10%. So you deposit $100 in your bank account now. You wait 1 full year until the bank transfers you your earned interest, 10%. So at the end of the year, you have $110, which is calculated by taking the $100 that you started with and adding 10% interest to it. So 100 times open parenthesis 1 plus 0.1 close parenthesis equals 110, right? In this case, interest is paid annually. Once a year, you see more money in your bank account. Let's change it a little bit. Interest is paid semi-annually. What does it mean? It means that you don't need to wait for 1 full year to see more money added to your bank account. After 6 months, you already have a little bit more. After another 6 months, you earn your partial interest again. So essentially, we are splitting the 10% interest over 1 year into 2 parts. 5% after the first 6 months and the other 5% after the second half a year. Let's do the math. Are we going to get $110 after 1 year? Let's see. You deposit $100 today. How much will you have in 6 months? 5% more, right? Which is half of the annual interest rate. And so you take 100 multiplied by 1 plus 0.05, and that's how you got 105, right? $105. Then $105 remains in your bank account for another half a year. So it gets reinvested for another 6 months. And now at the end of the year, you have another 5% on top of 105, not on top of $100. So what's the additional 5% of 105? It's additional $5.25. At the end of the year, we have 105 from 6 months earlier with 5% added to it. So you have 105 times, open parenthesis, 1 plus 0.05 equals $110.25. So with the annual compounding of interest, when you have to wait 1 full year to see the interest added to your account, you get $110 at the end of the year. With semi-annual compounding, you get $110.25. There's additional 25 cents. It's just a little bit, but it's something. And so the effective annual interest rate is additional, earning 10.25% on your money, rather than earning just 10%, which is the quoted rate. 10% and a quarter is the effective annual interest rate, EAR. And I also show how you could calculate $110.25 slightly differently, where you basically say that on your initial amount of money, $100 deposited now, you earn a 5% interest once, and then you earn a 5% interest for the second time on top of what you had, you know, half a year earlier. So $100 times 1 plus 0.05 raised to the second power. In general, in order to calculate the effective annual interest rate, EAR, when interest is compounded m times a year, we follow this formula. EAR equals, open parenthesis, 1 plus a fraction with quoted interest rate on top, m on the bottom, close parenthesis, the whole thing is raised to the power m, and then we subtract 1. So the fraction inside the parenthesis, which is quoted interest rate per year divided by m times per year, is nothing but interest rate per compounding interval. In our example with a 10% annual quoted rate and semi-annual compounding, we earn half of the annual rate after the first half a year, which is 5%. Then m is how many times interest is earned or compounded within a year. In our example with semi-annual compounding, it's twice a year. Now, let me show you how you can do this thing in the financial calculator. Let's turn it on. Let's clear everything just to make sure it's not going to reuse something that we have stored. Second, plus minus, enter. Let's increase the decimal places. Second, for decimal place, let's make it not 2 but 6. 6, enter. And now let's see how we can go from the 10% quoted annual rate to the 10.25% effective annual rate. You do the following. Second, 2. It brings up the text in the second row. That's what the key second really means. What does it say in the second row? Like right above the key with the number 2 in it. It says ICONV, which stands for interest conversion. So we want to convert our interest from the stated interest rate or the quoted interest rate to the effective rate. Take a look at what the display shows. NOM. Press either the up or the down arrow key. Just keep pressing. You will see that the display switches between 3 things: NOM, EFF, and C over Y. So go back to where it says NOM. NOM stands for nominal. It's the same thing as quoted or stated rate, the one that's given, the one that does not reflect any additional interest on interest going on. So you want to set the nominal interest rate in your financial calculator to 10. Press 10, enter. It's saved. Now press either the up or the down arrow key, right? And stop when you see C divided by Y, C/Y. It stands for compounding per year. What should this be changed to? With semi-annual compounding, or twice a year that the interest is earned, you want to set this to 2. Press 2, enter. So we enter 10% quoted rate. 2 times per year is how often the interest gets compounded within a year. And now press either the up or the down arrow key and stop when you see EFF on the display. It stands for effective. All you have to do now is press the button compute. The display now shows 10.25. The effective annual interest rate is 10.25%, which matches what we have on the slide, right? If your quoted interest rate is 10%, then we can think of other compounding frequencies. So we had annual once a year and semi-annual twice a year. And the ER would be 10%. If it's just once a year, then the effective rate is the quoted rate. And with semi-annual compounding, it's 10.25%, which we have just calculated. How about other frequencies? Well, you can think of, for example, earning interest quarterly, once a quarter, which is 4 times a year. In this case, the effective rate will be 10.381%. Or monthly, which is 12 times a year. The effective rate is even higher, 10.4713%. And this is actually very common in real life. A lot of things in life assume monthly compounding. Loans, credit cards, rents, most things are monthly, compounded monthly. Then you can think of weekly compounded or 52 times with an even higher effective rate. Daily, 365 times, even higher effective rate. The special case is called continuous compounding. That's when the frequency is basically infinity. In the calculator, you can basically change your frequency to, let's say, a bunch of 9s. It will work, or the formal formula looks like this. Exponent, and then you use the quoted rate, 0.1 in our example, and then from the whole thing you subtract 1. This is sort of as high as it can get, 10.5171% per year. Let's try one of these. So let's see once again how everything can be done in the financial calculator. Let's clear second plus minus, enter. Let's increase the decimal places. Second decimal place, let's make it 6. 6, enter. And now let's convert the quoted interest rate of 10% into the effective annual interest rate. Using, which one should we do? Let's do the monthly compounding, the one I said, which is very common in real life. Monthly compounding means 12 times a year. So after the first month, you have a little bit more money. Then that larger amount stays for another month and earns interest. And there is now interest on interest going on, and so on. In the financial calculator, you convert using the following steps. Second, 2. What's the nominal rate? That's the one that's given, 10%. You press 10, enter. Then either up or down arrow key. Keep pressing. Stop when you see compounding per year, C over Y. You want to change it to 12 times a year. 12, enter. Then again, either up or down arrow key. Stop when you see EFF, effective. All you need to do now is press compute. 10.471307. In my table, I rounded it to 4 decimal places for the monthly compounding, so it only shows 10.4713, but it's basically the same thing. In real life, I already mentioned there are a lot of examples of where interest rate is compounded more than once a year. Car loans, the payments on car loans, the payments on home loans, payments on any kind of loans are monthly. When you put money in a bank account, you deposit money, the bank actually calculates daily how much you earn in interest. Except it waits a month before it transfers the whole earned interest to you. So the banks actually, all banks actually use daily compounding of the money in your account.